works this time. We are starting chapter 8, and in my opinion, nice, easy break into the chapter. We are simply adding and subtracting polynomials. So a couple terms here so that you understand what is what. The first is a polynomial. Remember, the prefix poly just stands for many, kind of like reverting back to polygons. You know, that's just a general term. So a polynomial is a general term for anything with one or more terms in it. So if there's only one term, that is called a monomial, because mono stands for one. Binomial is 2. Trinomial would be 3 terms, and they don't have anything beyond that. So those are the specific ones. Remember, terms are separated with some are differences. So there's a plus sign here that separates it, and there's a minus sign and a plus sign. So that's why there are 3 terms. A monomial can just be a number. It can just be a variable, or it can be a product of a number and one or more variables. Okay. Remember that a monomial and in relation then a polynomial cannot have a variable in the denominator, which means it cannot have negative exponents. Okay, so if there's a negative exponent, ignore that for now, sorry about that, then it's not going to be a polynomial. So moving on, we have something called a degree of the monomial. The degree is simply all of the exponents added together. So if we just have a number or a constant, as it says, then the degree is 0 because there is no variable to add the degrees for. Okay, and then if we move on to a polynomial, if there's more than one term, the greatest degree of all the terms, so you look at all the terms and find the degrees of each, and then whichever one is the largest is the degree of the polynomial. Okay, so let's go on down here. First thing we're going to do is figure out if it's a polynomial, yes or no, then find the degree, and then decide if it's a monomial, binomial, trinomial. And I kind of have the first 2 done because I started recording once and it stopped me. So in that first expression, a lot of people think, oh, we can't have a fraction. Well, you can have a fraction, but what can't be down there is the variable. The variable's not down there. That's like saying 3/4 x. So it's just a number times a variable. It is a polynomial. It's actually one term, and there's only one exponent, and it's a 1, done. So 1 degree monomial. The next one, again, we see a fraction, but no variable in the denominator. So it is, yes, it is a polynomial. The degree then, a is 2, b is 1, and 1 is 0. Well, not 1 is 1, but there's no variable there, so that's a 0. So the biggest one would be a 2, and there are 3 terms separated by sums and differences. Okay, this third one, now we got a fraction, and look what's in the denominator. That's a variable, and so this is a no because k is actually to the -1 exponent, and it is in the denominator, and it's a division problem with a variable, so it's no, which then obviously don't answer those 2. And the last one there is yes, and there are actually 2 terms. Okay, so the degree of this first term would be 2 plus 3, or 5, and this one would be 3 plus 1 plus 1, also 5. So they're both 5, so obviously the biggest is still 5, and it is a binomial. Okay, what about this one over here in the box? Is this going to be a polynomial? And the answer to that is no, and because it has that negative exponent in for a. All right, so when you're writing polynomials, it technically can be written in any order. However, the polynomials that only have in one variable are usually written in standard form, meaning the terms will go from the biggest to the smallest. So take a look at their example. They only have x in this example. So 4x to the third, and then -5x squared, and then plus 2x and 7. So decreasing order of the variable. Okay, so we want to practice that because that is proper term. Now, if you have a whole bunch of different variables, that you can kind of throw that out the window. The only exception would be I would try and leave your constant as your last term. So take a look at this one. If I'm putting it in standard form, I'm going to put the 3x cubed first, then minus 2x squared, and then plus 1. Over here, the largest one is, believe it or not, a negative a to the third plus 4a squared minus 7a and plus 21 as very last. Okay, remember those signs out in front, whether it's a plus sign or a minus sign, those belong to each term. So even though this is a minus 7a, it's kind of the same as adding a negative 7a. So that sign has to go with it. All right, let's flip this baby over. What does it mean to add polynomials or subtract polynomials? Basically, we're combining like terms. And like terms means they have to have the exact same variables, the exact same. So if one has an A and the other one has a B, you can't put them together. If one has an A and a B and the other one just an A, cannot put them together. They have to be exactly the same. Okay, you don't necessarily, so they have this polynomial, and this polynomial. They're separating them with parentheses just to show you, but we're adding them. So once you see the addition, really you can ignore the parentheses and just combine like terms. So I like to underline them. So this is a 1 and that's an 8, so I got 9r squared. Then I have a 7r and a negative 2r, which gives me a positive 5r. And then the last ones, the two constants, 11 and 10, both positive, which gives me a plus 21. Okay, fairly simple. All right, let's look at the next one. We are again adding, so just don't worry about the parentheses. So we can just look for like terms, and we'll see here that this one we have a negative 5a squared, a positive 1a squared, and a positive 3a squared. So that's negative 5 plus 1 is negative 4 plus 3 is negative 1. So we got negative 1a squared. Whether you choose to put the 1 there or not, totally up to you. And then I have a positive 1a and a negative 4a, so minus 3a. And that's it. Oh, just kidding. Sorry. Forgot about my 9 plus 9 constant. Okay. So now, believe it or not, I'm not going to waste any more time because that's pretty simple. And the subtraction is about the same thing, except when we subtract, we add the opposite. So before we do anything, I'm going to make this an addition instead of a subtraction. What I mean by that is I'm going to add the opposite. So I'm going to change that to a plus, and then I'm going to change all of these terms that is being subtracted to the opposite. So I'm going to make this a positive, which means that n becomes negative, the 2n cubed becomes positive, and the 1 becomes negative. Once I do that, I ignore my parentheses and I combine like terms just like an addition problem. So I have an n cubed and a 2n cubed, which gives me a 3n cubed. I don't have any n squareds, so I'm going to move on to the 3n and the minus n, so plus 2n, and then minus 10 with my constants. So with subtraction, you're just adding a step. The step before, changing the signs. So the second one, going to be positive, and it's going to make this negative, this positive, and this negative, and now combine like terms. So a negative 17 plus 1 is a negative 16x to the third. A positive 6x squared and a negative 2x squared would be plus 4x squared. And now check this out. This is the only x I have, so I'm just going to write minus x and plus 7. And there you have it. So your assignment is on the additional sheet you have. Should be pink. I'm not even sure what that is, so just check the top. If you have any questions, you can come and see me, but I think you're going to be fine. You do not have to rewrite every problem for today. I'm going to let you go on that, so you're welcome. And that's all I got. So good luck.